Hello everyone, and welcome to the first episode of Khalil Cheats. Today we'll be talking about chapter 1, which is about tangential motion. In other words, this is motion on a straight line, such as the movement of a car on a road or a person running. Also the movement of an object through the air, whether it's something that's been shot in the air, like a football or a bullet, or something that's simply free falling in the air, such as someone jumping from a building if they study physics too much. Now, in chapter 1, the SAT likes to focus on the figures. So they might give you a figure where you have two variables plotted against each other, a y-axis versus the x-axis. And you will have to decipher what the figures mean, okay? What does the slope mean? Is there an increase? Is there a decrease? Is there no change? Okay? And we have three cases of those figures. Case 1 is going to be position, okay, as the y-axis versus time as the x-axis, okay? Now, if you plot position versus time, this means that you should get the slope of velocity, okay? So your slope is going to be velocity. Let's give you this first plot here and let's see if you can decipher what's going on. All right, as you can see here, we have position as y, time as x, and you can see this horizontal line. So this horizontal line represents velocity. And as you know from math, any horizontal line has a slope of 0. And if the slope is 0, this means that the velocity is also 0. So what can we conclude about this object? Is the object moving? No, because the velocity is 0. Is it accelerating? Of course not, because when the object is not moving, it obviously has no acceleration as well. All right, let's give you another case here. Okay, so here we're gonna have displacement versus time. And by the way, position or displacement are the same exact thing. So if you plot displacement versus time and you get this parabolic graph, then this means that the velocity is changing, right? And it's going up. So this means that the velocity is increasing. But because the shape is parabolic, this means that the velocity is increasing at a constant rate. Now, I've already said that the velocity is increasing, meaning that there has to be acceleration. But because I said the velocity is increasing at a constant rate, because the rate is constant, this means that the acceleration is constant. And in physics, a constant acceleration is called a uniform acceleration. All right? Now, let's consider the third example here. I'm going to take this other figure of position versus time. And as you can see here, what I have is this line, this straight line, which has no curves, right? It's also going up, but it is not parabolic. It's not curved up or curved down. It's simply a straight line that is not horizontal, and it's also going up. Now, of course, if the speed is constant, this means that there is no acceleration. Now, in another chapter of my book, The Khalil Cheats, where even though the speed is not changing, okay, there is still acceleration. But that's not covered in this chapter. In this chapter, we only focus on the graphs, and in the graphs, we don't assume circular motion. We only assume motion on a line or motion in the air, okay? So here, if you see a straight line between position and time, and the straight line is going up, or maybe even it's going down, this means that the speed or the velocity is constant and there's going to be no acceleration. All right, let's take a fourth example here. I'm going to take another position versus time graph, and as you can see here, it is curved down. All right, so because it's curved, okay, this means that the velocity is changing, and as it curves down, okay, as you can see, the slope becomes more. The line becomes steeper. When the line becomes steeper, the slope is becoming larger. And what's the slope between position and time? The slope is velocity. So basically, the velocity is increasing over time. All right, and here the slope is going down, right? The line is going down, which means that the velocity is becoming negative in magnitude. Okay, maybe the object is heading downwards, maybe the object is heading left or south. That's not of relevance to the question, but basically because the line is going down, the velocity is becoming more negative, but that does not mean it's decreasing. In fact, as I said earlier, the velocity is increasing because the slope is becoming more steeper. All right? So remember, if there's a curved line, whether it's curved up or down, this means that the velocity is changing. Okay? The velocity is changing. All right? Now, let's take another figure here. Let's see. Okay, let's erase that. Look, here I also have distance versus time, and by the way, displacement or distance for the purpose of graphs means the same thing. So, it starts to curve, okay? And as you can see here, the line is becoming steeper, which means that the velocity is increasing, okay? So accelerating. Then the line becomes a straight line, right? So even though it is going up, but guess what? The line is a straight line, all right? And so because a straight line is going to be a constant speed, okay? We're going to have a constant speed. As I told you earlier, if you have a constant speed, this means that there is no acceleration. And then it starts to curve with a less steeper line. The slope is becoming less, which means that the object is slowing down, okay? The object is what? Is slowing down because it's curving down, okay? Look at the slope. It's becoming less steep, which means it's slowing down. And then it comes to a horizontal line, which means that the object stops moving and becomes stationary, all right? Now we're going to take another case. We're going to go with this figure here. All right, as you can see here, I have displacement versus time. And here I have a highest point, okay? And whenever you see a highest point, okay, where it separates the left half that's going up and the right half that's going down, this highest point represents a zero velocity. Even if it's for a millisecond, okay, it's a zero velocity for that millisecond. Now, we will see this motion later on in a projectile motion where we throw the object up, slows down to a zero for a millisecond, and then starts to increase back again. So, what can we tell from this figure? All right, that first of all, this is the first half of the flight. The object is going up and then it's going down in the second half of the flight. All right. Now, as we're going up, as you can see, the line is becoming less steep, which means the velocity is becoming less. And then we have this straight line for a very small period of time, and this straight line means a zero velocity for that very small period of time. And then the line becomes steep again and increases in steepness, meaning that the velocity is increasing. Now, when we are going up, the velocity is positive. When we're going down, the velocity is negative. When the line becomes less steep, the velocity is decreasing. When there's a straight line, the velocity is zero. When the line becomes more steep, the velocity is increasing. Okay? Good. Let's go ahead and take another figure. All right. Position versus time again, which means I have velocity here. Straight horizontal line, which means a zero velocity. Then we have a straight line that is not horizontal and it's heading up. Because it's a straight line that's heading up, this means that we have a positive velocity, but it's a constant velocity. And again, in the terms of figures, if you have a constant velocity, you must have a zero acceleration. Then the velocity becomes zero again because we have a horizontal line, and then becomes a straight line that's heading down. If we have a straight line heading down, this means that we have a negative velocity that is constant, which means zero acceleration. So basically here we have a zero velocity, a constant positive velocity, a zero velocity, and then a constant negative velocity. Okay, let's take another figure here. That's also position versus time. Okay. Position versus time. Okay, and as you can see here, the slope is becoming, first of all, it's curved, which means that the velocity is changing. Okay, and secondly, it's becoming less steep, which means that the velocity is decreasing. Okay, the velocity is decreasing. Now, because we're only going up, we're not going down, this means that the velocity is positive, but guess what? It is decreasing. Okay. Now, we finished the case 1 of position or displacement or distance versus time. And that's it for today. We will be covering the other cases in the next episode. See you later.